Welcome back, guys, and in this clip we are going to talk about the effect of a sand while using the organic mesh. So let me play the timeline and show you what we have achieved. So this is the final result, and definitely we are going to utilize the nParticles as well as the nConstraints, which we have already learned in our previous clips, and the technique is simply going to be the same. We are going to utilize the nConstraints. Yes, however, I do acknowledge that we have some less amount of the particles because this is only for the demonstration purpose. And let me show you one another. And in this case, I just try to, change the overall radius of the particles. As you can see, we have some lot of, jittering, or you can say unevenness in the particles, because I just try to play around with the per particle radius of these, sand particles. But it wasn't, like that much impressive. So go back to the previous settings, and in this case particularly I wasn't like that much satisfied, because you can see there's a lot of fluffiness and there's a bounciness in the particle clustering. Well, one reason is also that we are using some lesser amount of the particles, but still it's not like that much great and interesting. So finally I ended up with result like this. In this case, you can see how beautifully the cluster of the particles is converting them again into the scattered pieces of the particles. Well, the simple trick is that I've simply animated the values of the glue strings. So this is giving me quite nice result, and what I got to realize later on, that we can give some balance between the values. Like, it's not required that first we have some good clusters, and then secondly we are trying to break them again into a kind of scattered particles. So what I believe, so that we should give some perfect balance between the clustered particles as well as the scattered particles, so that we shouldn't be having a lot of bounciness, but we are also not having entire particles with the behavior of scattered particles. I mean, we should have some nice balance. So let's do one thing. Let's get started with this effect, and let's go inside the Maya and start creating our effect. Alright, so we are inside the Maya, and this is the mesh which I'm going to use for the creation of the sand particles. Now, as you know, we are having only one limitation, that is the total particle count for our demonstration purpose, because I got to realize that once I start playing the timeline, the result is really getting slow. This is due to because of the large amount of the particles. So in this example I'm using some minimal values only, but they are quite sufficient in clearing out your concept, and later on you can definitely upres your particle counts by having a higher number of resolutions to get some more natural and realistic details. So let's select this piece of the geometry and go inside the FX menu. Over here we have nParticles, and use the command fill object, and the 100 resolution is quite high, so I'm going with a resolution of, let's say, 75, and hit the option particle fill. And once you click this, you need to wait for a while, because this will take a little bit amount of time to get itself refresh. Alright, so here we go. Now we are having hardly 22,000 particles. Well, that would be sufficient in explaining the stuff. Later on we can definitely increase this, and I'm providing you with this file, and I recommend you, while doing your own experiment, take this value to something beyond 150, or let's say you must use a value of 150 for the resolutions, and try achieving the total particle count somewhere around to 350,000 particles, or maybe 500,000 particles. Alright, so with that you can get a very realistic and nice results. So let me just hide this mesh, and now we have the particles. As you can see, the particles are we are still not able to collect enough resolutions for the fingers, but not a problem. So let me just select this and change the particle the particle shading type from the points to the sphere. Here we go, and let's say we can add some nice color to that also. So let's use the nucleus plane as well, and let's increase the substeps to 10 with the max collision iterations to the 8, and all the settings are pretty much the same. Yes, we can still utilize the plane bounds to maybe 0.5, so that we can have some nice motion of the sand particles. Go inside the nParticle shape node. Over here we can utilize the self collisions. Alright, go with the value of 1, and let's say 3 for the stickiness. Increase the max self collide iterations to a value of 6. Alright, once I play the timeline, And let me just increase the time slider to 200 frames, and let's play the timeline and see what we have. So the simulation is a bit slow, I acknowledge this. The frame rates are dipping, but still it's not a problem. Simple process to achieve a look and feel of a sand, but yes, we have a lot to do. So now we are required to add some interesting constraints so that we can have some particle clustering. So what we can do, instead of just simply dragging the particles, you can still use the different type of selection tool so that we can have some nice and interesting shapes, and that's totally the choice of the user, but I highly recommend you to go with this kind of a behavior so that we can have some really nice randomness inside the you know the particles. And just like this, and make sure you don't have a lot of area, and let's say we go with this one, and this much is fine. Alright, so let's say we go with the hand also, no problem, and with some little amount of the face. Okay, so let's go inside the end constraint and use the component to component, the same workflow which we already have achieved in our previous clips. Hit the option create constraint. Now let's select the constraints and select them. We are using the constraint method as a spring and the connection method to within max distance. And inside this, let's use a value of, let's say, 0.35, or we can use a value of 0.25. That's totally our own artistic decision. And now it's time to work upon this strength and the glue strength. So if we don't dip down the value, the particle will remain in the cluster. Let's do one thing. Let's go with the default value first. Let me hide the constraint for a while and play the time slider and see what we have. And definitely there is a slowdown, but yes, I can see some nice and interesting particle clustering as well as a result of the constraint. And let's do one more thing, guys. We should also add some lights to see actually the thickness, or you can say the clumping of the particles, because right now the total workflow is totally mixed up, so I just cannot able to see the definitions of the clumping and all. So I'll do one thing. I'll take a pause, and you can see, yes, definitely we have some lot of nice interesting stuff over here. So let's do one thing. Let's add some lights. Go inside the Arnold and go for the lights. Let's have a minor directional light, and in this case I am going to render the entire thing with the help of the Arnold, and this we are going to cover in our next module, so we don't need to worry for the lighting stuff and all. Enable the shadows, and here we go, very nice and interesting. So let's also have some ambient light to get the details of the shadows, and let's dip down the intensity to maybe value of 0.1 or 0.2, and you can simply have some blue light. That's nice. Alright, and let's say value of 1, value of 0.3, 0.25 is fine. Let's select the light and increase the color to a bit yellow and increase the intensity to maybe 1.5, and that's nice. So with the limited amount of the particles with low resolutions, we are having some this kind of the overall output, which is, yes, a bit less in the resolutions, but we don't need to worry about this because we have already achieved this result with a very high amount of the particle count, that is somewhere on close to 350,000 particles. Now let's do one thing. We have some interesting information of the particles over here. It's time actually to animate the values of the glue strength. Alright, if we just want the particles to remain stick with each other for frame length of, let's say, 100, so we can simply just animate the values of the glue strength. So for that we need to go inside the dynamic constraints and use the value of glue strength, of course. Let's do one thing. Let's roll it back, and let's first of all disable the nParticles. Let's also disable the nConstraints. Okay, they are already, so yeah, here we go. nParticles and constraint both are disabled. Now we can simply key down the values of the glue strength. So put a key over here with the glue strength value 1, and let's say at frame 100 or maybe at frame 120 you would like to go with the value of point, let's say 135 or maybe around 0.15, whichever suits to us. Put a key over here, and let's do one thing. Let's rewind the stuff back, and let's enable the constraint as well as the nParticles, and let's have a simple play blast. Alright, so we are back, and now let's play the timeline and see what we have. So this is the result we are now getting, and notice that slowly these clusters are simply getting break. But I guess the value of 0.25 or let's say 0.135 is also, little less. We can still, crank this up with the value of, let's say, 0.15, so that we shouldn't be having that kind of a jerk. And one another thing that which is responsible for giving a quick, conversion from cluster to the scatter, and this is due to the, you know the in and out tangent. So I think so we should use the linear value. So go with this, a linear curve. All right, and the last value is 0.135. So let's say we should have a value of somewhere around, let's say, 0.145 or maybe 0.15. All right, so I also like to show you the final render of the high resolution version of particle, approximately 350,000 particles with Arnold rendering engine. And here we go with the final render. And in this particular case, I'm not using the constraint, but yes, I will definitely like to use them because that was a little old kind of, render. So not a problem. We can still use the constraints, and we can still provide some nice and interesting keyframes to the glue strength to have a final look and feel. Alright, so that was the look inside the sand particles, and with this our module is now finished. Now let's take a look inside the summary of our module. And here is the summary of our module. So we started off with fill object command. With the help of this command, we actually fill the nParticles inside the polygon mesh while using the appropriate resolutions. Then we adjusted the attributes of friction and stickiness inside the collision attributes of nParticles. Finally, we have the nConstraints. We use nConstraints simply to create the clustering or clumping of the particles. And then inside the nConstraints, we use a type component to the component. So with the help of this, finally we have sand particles workflow. Alright, so with this our module is now complete. Now it's time to do the rendering of the sand particles with Arnold rendering engine. So let's get started with the next module where we have the rendering of sand particles. Alright, so see you there.